I want you to try something right now. Close your eyes and picture the biggest thing you've ever seen in your life. A mountain, an ocean, a city from an airplane window at night. Now I'm going to spend the next 15 minutes destroying that sense of scale completely. Because the universe is not big in the way we mean when we say something is big. It is big in the way that makes the word big feel embarrassing for even trying. And the strangest part? Most images of the universe are lying to you. Not on purpose, but lying nonetheless. This is Mind Frontier, and today we are going somewhere your brain genuinely cannot follow. Every photo you've ever seen of space is filled with light. Galaxies, nebulae, star clusters, color everywhere. Beautiful, overwhelming, and deeply misleading. Here is the truth. Visible matter, everything we could ever see, touch, measure, or interact with, makes up less than 5% of the universe. 5%. The rest is dark matter and dark energy. We know they exist only because without them, the physics stops working. No one has ever directly seen either one. And even that 5% of visible matter doesn't spread evenly through space. It clumps along the edges of enormous empty bubbles, like soap foam. Thin walls of galaxies surrounding vast regions of absolute nothing. What we see when we look at the night sky, all those points of light, all those structures, that is the exception. The universe is not a place full of things. It is a place full of nothing, with thin threads of something stretched across it. That realization alone should sit with you for a moment. Let's start somewhere familiar, our own solar system. Most people know it's large. Almost everyone underestimates just how large. Pluto, and yes, I still count it, sits about 6 billion kilometers from the sun on average. Light takes 8 minutes to reach Earth from the sun. To reach Pluto, that same light needs over 5 hours. New Horizons, the fastest probe humanity has ever launched, took 9 full years to reach Pluto. 9 years of travel, and it still hadn't left our own solar system. When it finally arrived, it had just 30 minutes to collect its most important data before sailing onward into the dark. And Pluto isn't even the boundary. The Oort cloud, the outermost shell of the solar system, extends up to a full light year away from the sun. We have never directly observed it. We infer it exists from the behavior of comets that occasionally drift inward, like notes sent from the edge of something we've never seen. Voyager 1 left Earth in 1977. Today, it sits roughly 23 billion kilometers away. To fully cross the Oort cloud at its current speed would take approximately 30,000 more years. Of what lies beyond our doorstep, we have explored essentially nothing. The nearest star to our sun is Proxima Centauri, 4.2 light years away. Now, a light year is the distance light travels in 1 year, about 9.5 trillion kilometers, and Proxima is 4.2 of those away. With New Horizons, our fastest spacecraft, the trip would take approximately 70,000 years. 70,000 years ago, humans were painting caves in Europe for the first time. We would not arrive at the nearest star carrying anything we recognize today. Not a language, not a government, not a memory of why we left. Interestingly, Proxima Centauri has a planet, Proxima b, sitting right in the habitable zone. Liquid water could theoretically exist there. But Proxima is a red dwarf. It fires intense radiation flares regularly. Whether anything could survive there, let alone thrive, remains deeply uncertain. Our nearest neighbor, 4 light years away, completely unreachable with everything we've ever built. The Milky Way contains somewhere between 200 and 400 billion stars. That sounds dense. It is not. The average distance between 2 stars in our neighborhood is several light years. Even within our own galaxy, the stars are separated by distances that make the gap between Earth and Proxima feel like a short walk. And here's something worth sitting with. In about 4 billion years, Andromeda, our nearest large neighboring galaxy, will collide with the Milky Way. 2 entire galaxies crashing together. And the probability of any 2 individual stars directly colliding? Astronomically low. Galaxy collisions are, in essence, the slow blending of 2 vast empires of emptiness. The Milky Way itself is roughly 100,000 light years in diameter. Some estimates push it to 200,000. Our Sun sits about 26,000 light years from the center. Not at the heart, not at the edge. Somewhere in the middle of nowhere, inside a galaxy that itself consists mostly of nothing. And here's a point that doesn't get enough attention. The speed of light is not a barrier we'll eventually engineer our way past. It is a physical law. The closer any object with mass gets to light speed, the more energy is required to accelerate it further. To actually reach the speed of light requires infinite energy. It is not a ceiling we'll break through. It is the wall at the end of the room. Andromeda is 2.5 million light years away. On a very clear night with no light pollution, you can see it with the naked eye. A faint smudge in the constellation of Andromeda. When you look at it, you are seeing light that left that galaxy 2.5 million years ago. Our ancestors had not yet developed stone tools when that light began its journey to your eyes. We never see the universe as it is. We only ever see how it was. Andromeda belongs to what's called the local group. Roughly 50 galaxies held together by gravity within a radius of about 10 million light years. Beyond that, the next comparable galaxy cluster, the Virgo cluster, sits 65 million light years away. And the space between these clusters is another category of emptiness entirely. In the Milky Way, there are at least stars, rare but present. In intergalactic space, there is perhaps 1 atom per cubic meter. No dust, no gas, no magnetic field pointing anywhere in particular. Light travels through that space and hits nothing. It simply continues, indefinitely. When you zoom out far enough, the universe reveals a pattern. Galaxies aren't randomly scattered. They connect into clusters. Clusters merge into superclusters. Superclusters stretch into filaments, thread-like structures hundreds of millions of light years long, forming a vast cosmic web. Our own galaxy belongs to a supercluster called Laniakea, only fully mapped in 2014. It spans 520 million light years and contains around 100,000 galaxies, all of them, including us, flowing slowly toward a gravitational center we call the Great Attractor. Between the filaments lie the voids. The Bootes void, discovered in 1981, is approximately 330 million light-years across. Where thousands of galaxies should exist based on average cosmic density, only a few dozen are found. Voids form because gravity pulls matter outward toward the filaments over billions of years. The void expands. The isolated galaxies left inside develop differently. Fewer collisions, less gas, different evolutionary timelines. Loneliness changes galaxies. That sentence is stranger the longer you sit with it. The largest known structure, the Hercules Corona Borealis Great Wall, is estimated at 10 billion light-years across. So immense that some scientists question whether it qualifies as a single, coherent structure. At this scale, the universe should look uniform. The fact that it doesn't is not yet fully understood. Here's where it gets genuinely difficult to process. The most distant galaxies observed by the James Webb Space Telescope, some more than 13 billion light-years away, show us what the universe looked like when it was less than 1 billion years old. Those galaxies may look completely different today. Some may no longer exist. We do not see the universe as it is. We see light. And light takes time. Look far enough, and you hit the cosmic microwave background, radiation from an era when the universe was so hot and dense that light couldn't move freely. That is our hard observational limit. Not darkness beyond it, a physical wall made of the past. The universe is expanding, not into anything. Space itself is stretching, and the further apart 2 points are, the faster they recede from each other. Some galaxies are already moving away from us faster than light can travel, not because they're moving through space, but because the space itself between us and them is growing. Light sent from those galaxies today will never reach us. They are already beyond our forever. And the expansion is accelerating, driven by dark energy. This means that in a few trillion years, every galaxy outside our local group will have drifted past our observational horizon. A civilization existing then would look into the sky and see an apparently isolated universe, no evidence that anything else had ever existed. They would ask the same questions we ask today, and they would have no way of finding the answers. We sit on a pale rock orbiting an ordinary star, one of hundreds of billions in a galaxy that is one of trillions in the observable universe. And the dominant feature of all of it, the overwhelming characteristic of the cosmos, is not abundance. It is separation. The stars, the galaxies, the filaments, all real, all extraordinary. But they are thin threads stretched across a darkness so vast and so complete that the lights we see are barely a rumor. What lies beyond our event horizon we will never know. And somehow, that is the most human thing about all of this. We are a species that looks into an incomprehensible void and refuses to look away. If this left you feeling small, good. That's what the frontier feels like. Subscribe to Mind Frontier. New videos every Tuesday and Friday, where human curiosity meets the unknown. I'll see you at the frontier.